What impeccable timing! At the very moment NASA's servers flickered offline, the rarest event in modern astronomy unfolded above the red planet. 3I Atlas, our third confirmed interstellar visitor, has just brushed past Mars. As of October 4th, 2025, the object is now drifting away from its closest approach, still less than 30 million kilometers from the Martian orbit. Just yesterday, on October 3rd, it made its nearest pass to the planet, a moment astronomers had waited months to witness. But right now, imaging is almost impossible. The sun's glare dominates this sector of space, hiding the object behind a veil of plasma and light. That leaves only one vantage point: the spacecraft orbiting Mars itself. Mars Reconnaissance Orbiter, ExoMars Trace Gas Orbiter, Mars Express. All of them were aligned for this exact encounter, and yet, almost every NASA feed has gone silent. A government shutdown, they say. At precisely the same moment, humanity needed real-time updates the most. To some, it feels like coincidence. To others, it feels deliberate. When an object from beyond the stars glides this close to one of our worlds, and the data stream suddenly vanishes. Questions are inevitable. Tonight we trace what happened before the blackout, the leaked frames downloaded by citizen scientists, the faint streak across the Martian night sky, and the growing suspicion that 3I Atlas is not behaving like a comet at all. Because this time, it's not just another visitor, it's a question from the dark, and it may have arrived right when we stopped listening. For weeks, NASA had been preparing for this encounter. High-rise cameras aboard the Mars Reconnaissance Orbiter were scheduled for a precise observation window, while the European Space Agency's Trace Gas Orbiter and Mars Express had both adjusted their orbits to capture spectral data. Everything was aligned. Every instrument, every antenna, every team on standby, until October 2nd, when something unexpected happened. Shortly after midnight, UTC, telemetry updates from several Mars assets stopped appearing on NASA's public servers. The agency cited temporary data routing issues linked to the U.S. government shutdown. But to the global community of amateur astronomers and open data enthusiasts who had been watching closely, the silence seemed too well timed to ignore. For years, NASA's planetary data has been mirrored on open access portals, repositories that allow citizen scientists to download raw image files directly from spacecraft archives. Normally, every orbit of the Mars Reconnaissance Orbiter uploads hundreds of these frames. But on October 2nd, during orbit 14281, the exact orbit predicted to intersect 3I Atlas's projected line of sight, the feed went quiet. No files, no previews, no logs. And then, for a few brief hours, something extraordinary happened. A user from Florence, Italy, known online as AstroDrew, noticed a new file identifier appear on a lesser-known mirror server belonging to the European Space Agency. The file name was simple: Atlas IM3 RAW 093.img, a few megabytes in size. No description, no metadata. Within minutes, the file was downloaded, duplicated, and shared across a small Discord group of open data researchers, the kind of community that scours telemetry logs for fun. They opened the file using public high-rise image tools, and what they saw stunned them. A faint diagonal streak cut across the frame, bright, consistent, and slanted against the backdrop of Mars' star field. It wasn't aligned with the motion of the planet's rotation, nor with any known satellite trajectory. It wasn't a cosmic ray artifact or compression glitch. It persisted identically in each channel of the composite image. Whatever it was real, and it was moving. AstroDrew posted the discovery to X, formerly Twitter, tagging several planetary scientists and using the hashtag #BUMP3IAtlas. Within an hour, the post went viral across the astronomy community. One reply came from Dr. Karen Ito of the Planetary Science Institute. If verified, this would be the first optical confirmation of 3I Atlas from the Martian system, a remarkable achievement, if NASA didn't pull the data first. But by morning, the file was gone. The ESA mirror returned a 404 error. The post remained, but the evidence, the original download source, had vanished. By then, dozens of users had already mirrored it. Analysts confirmed the file's checksum matched NASA's data format perfectly. The Coordinates in the frame placed the object precisely where 3i Atlas was expected to appear during that orbital pass. So, if the image was authentic, the question shifted from what they had seen to why it disappeared. Why was the public feed interrupted only during the window of 3i Atlas's closest approach? And why, hours later, did NASA's official update page acknowledge a temporary suspension of high-rise image delivery due to system maintenance? For many, it was a small detail, a simple case of bad timing. But for those following the object's every move, it felt like déjà vu, a pattern seen before with Oumuamua, with Borisov, and now again. Each time an interstellar visitor passed close enough for high-resolution observation, something, technical or bureaucratic, seemed to get in the way. Maybe it's coincidence, maybe it's not. Either way, the leak was real, and the faint streak across that Martian sky may have been humanity's only unfiltered glimpse of an object from another star system. The image itself is unremarkable at first glance. A raw, grayscale frame, filled with the usual digital noise and the faint curve of Mars' limb in the corner. But once adjusted for brightness, contrast, and gamma, the anomaly reveals itself. Cutting across the lower quadrant is a streak no wider than a few pixels, yet it burns brighter than any star in the frame. The line isn't perfectly straight. It curves ever so slightly, too smoothly, too consistently, as though tracing an arc rather than a random reflection. The Discord group began dissecting the data immediately. AstroDrew shared his screen with the others. A group of programmers, image analysts, and hobby astronomers from different time zones. They compared frames, cross-referenced timestamps, checked against catalog satellites, cosmic rays, and even Martian dust reflections. None fit. When the exposure settings were overlaid with Mars's rotational data, something else stood out. The streak's motion was diagonal relative to the star trails, a pattern consistent with an object passing rapidly through Mars's sky, not one stationary or orbiting the planet. To confirm, another user from Kyoto applied a color reconstruction filter based on known high-rise parameters. That's when something unexpected appeared. A faint halo, bluish in tone, surrounding the core of the streak. Not the broad fan of dust we associate with comets, but a tight ionized glow, symmetrical, almost controlled. Within hours, the discovery spread through private astronomy channels and message boards. Amateur analysts began posting their own processed versions of the frame, and each showed the same thing, a luminous, needle-like structure with a dim aura, reflecting light in a way that didn't quite match typical cometary scattering. "It's too clean," one post read. "No debris, no tail, no radial gradient." Others speculated that the light curve was artificial, perhaps a result of structured reflection from a metallic surface, or even a rotating geometry. A few went further, suggesting it looked like a long, cylindrical body, tumbling end over end. Theories multiplied. Could it be 3i Atlas caught at just the right angle, with its coma compressed by the solar wind? Or something else, something shaped? Meanwhile, attempts to verify the raw file became increasingly difficult. NASA's planetary data system, which typically mirrored these archives within 24 hours, listed no record of orbit 14281. The metadata was missing entirely. When one user contacted the PDS help desk, they received a generic reply. "This dataset is under review for integrity validation. Please check back later." But the independent checksum analysis was conclusive. The data structure, byte order, and timestamp header matched those of genuine high-rise frames. No manipulation, no fabrication. In short, the file was real. What it captured, however, remains uncertain. By the evening of October 4th, astronomy Twitter was ablaze with speculation. The object's speed, if extrapolated from the streak's angle and exposure time, aligned perfectly with projections of 3i Atlas, around 60 kilometers per second relative to Mars. The size of the luminous region suggested a nucleus at least 4 to 5 kilometers across, consistent with Harvard's preliminary estimates. Still, what unsettled researchers most wasn't its motion or its mass, but its behavior, the lack of a visible dust tail, the symmetrical glow, the silence from NASA. Together, these details painted a picture no one quite knew how to interpret. And as the official channels stayed dark, One conclusion began to surface across discussion threads. The image might be genuine, but the story behind it was being withheld. As the online speculation grew, official science teams quietly resumed their work. Even amid the government shutdown, several research groups, including teams from Harvard, the European Space Agency, and Japan's National Astronomical Observatory, had already compiled months of data on 3I Atlas's trajectory. Their findings, released through independent channels, painted a picture both fascinating and deeply confusing. Between May 15th and September 23rd, a total of 227 observatories worldwide had submitted their positional measurements to the Minor Planet Center. Using these, a Harvard team led by Dr. Richard Kluta, Avi Loeb, and Peter Vess calculated not just the object's orbit, but also its subtle deviations from a purely gravitational path. That deviation, known as non-gravitational acceleration, is the signature of gas jets venting from a comet's surface. When solar heat vaporizes ices, the escaping gas gives the nucleus a tiny push, gradually altering its course. In 3I Atlas's case, however, the effect was barely detectable. Less than 15 meters per day squared. That's remarkably small, especially considering how visibly active the object appears. Spectral data shows strong carbon dioxide emission, meaning its surface is venting material. But if it's truly outgassing that much gas, why isn't it being shoved around more? Dr. Loeb's interpretation is simple. The nucleus must be massive, so massive that the escaping jets can't significantly alter its trajectory. From their calculations, the team estimated its minimum mass at over 33 billion tons, with a core roughly 5 kilometers wide, not counting the diffuse halo of dust and plasma around it. That makes 3I Atlas not only the largest interstellar object ever detected, but also one of the densest. And that's where the mystery deepens. Comets from other star systems are expected to be small, debris-sized remnants ejected during planetary formation. We should have found dozens of smaller ones before encountering a behemoth like this. But we didn't. Statistically, 3I Atlas shouldn't exist, or at least not as the first of its kind. Then came the second anomaly. Composition. Spectroscopy from Chile's Cerro Paranal Observatory hinted at traces of nickel without iron, a highly unusual combination. In natural bodies, those two elements tend to appear together. Nickel without iron implies extreme refinement, or an environment unlike anything found in known protoplanetary disks. In a recent interview, Loeb called it provocative, suggesting that, while natural explanations remain possible, a technological origin cannot be excluded. The phrasing ignited immediate backlash from more conservative scientists. Dr. Helene Park from NASA's Jet Propulsion Laboratory pushed back. All current evidence remains consistent with a natural object. Spectral inconsistencies can arise from instrumental noise or calibration limits. Extraordinary claims require extraordinary evidence. Still, the questions persisted. If 3I Atlas is purely natural, why does its coma remain so faint despite its proximity to the Sun? Why hasn't it fragmented or shed a tail, as comets typically do under that level of radiation? And why, once again, did the public data stream fall silent during its most critical observation window? ESA sources quietly confirmed that their trace gas orbiter did capture multiple frames during the flyby, but those images are under review for telemetry alignment. No release date provided. So, for now, all we have is a handful of pre-shutdown data, a leaked Mars image, and a series of unexplained anomalies. Somewhere out there, 3I Atlas continues its journey toward the Sun, accelerating to nearly 68 kilometers per second, with its ionized shell expanding by the hour. Each day it brightens, reflecting sunlight from its strange, symmetrical coma. And with every kilometer it travels, one truth becomes harder to ignore. The more we learn about it, the less it behaves like any comet we've ever known. As the data trickled in, theories began to multiply. Every camp in the astronomical community seemed to draw a different conclusion from the same mysterious evidence. The conservative view, held by most NASA and ESA scientists, is that 3I Atlas is a comet, albeit an exceptionally massive and unusually stable one. They point out that nature often surprises us. For decades, astrophysicists assumed that hot Jupiters, giant planets orbiting close to their stars, couldn't exist until we found dozens. 3I, Atlas, they argue, might simply be another outlier, a cosmic oddity that forces us to expand the boundaries of what's possible. Dr. Helene Park summarized it bluntly. We've seen objects behave in strange ways before. It doesn't make them alien, it makes them interesting. But others aren't so sure. Dr. Avi Loeb, the Harvard astrophysicist whose name became synonymous with controversy after his Oumuamua papers, noted that 3I Atlas's combination of size, symmetry, and non-gravitational behavior falls well outside statistical norms. If the object truly possesses an ultra-dense metallic core, its surface might be engineered to resist sublimation, or even to maintain stability under solar heating. Loeb stopped short of calling it artificial, but his phrasing was deliberate. When an object moves as if obeying guidance rather than chance, we should not dismiss the possibility too quickly. That single line set off a storm. Mainstream astronomers accused him of sensationalism. Citizen scientists accused NASA of secrecy. Within 48 hours, Reddit threads with titles like "NASA's missing Atlas data" and "The Mars leak they won't talk about" flooded science forums. Meanwhile, independent analysts began running their own models. One physicist from Kyoto simulated the object's trajectory under standard cometary mass assumptions. The result? The model diverged from the observed track within days. Only by assigning it a density near that of solid nickel, far heavier than typical ices, could the path align. Nickel again, the same element that kept appearing in the spectral readings, without its usual companion, iron. Speculation reached its peak when a European amateur astronomer, using archived data from the ExoMars Trace Gas Orbiter, claimed to have detected periodic fluctuations in 3I Atlas's brightness, repeating every 47 minutes. That pattern could be noise, or rotation, or, as some suggested, a controlled spin. The claim was never verified, but the timing was enough to ignite a firestorm. For some, the mystery of 3I Atlas became a litmus test, a reflection of how one sees the universe itself, either as a place governed entirely by randomness and physics, or as a cosmos, where intelligence might occasionally leave its fingerprints. Public fascination only grew when journalists began to connect the blackout with the object's flyby. A viral headline from Skyward, daily read, "NASA goes dark as interstellar visitor passes Mars." The story offered no proof, yet the implication was clear. Something had been seen, and then silenced. In truth, the simplest explanations might still hold. Solar glare could have disabled sensors. Telemetry systems might have failed during the government shutdown. The missing data could simply be bureaucracy, not conspiracy. But the optics, the timing, the gaps, the leaks are what fuel imagination. Because when an object from another star brushes by one of our worlds, and every telescope that could have seen it suddenly stops reporting, people notice. And even if it's all coincidence, it's a strange kind of coincidence. One that leaves a single, haunting question, echoing through both the scientific community and the public alike. If it isn't natural, then what exactly are we looking at? On September 25th, the Sun unleashed one of its more violent moods, a coronal mass ejection. A massive burst of charged plasma erupted from its surface and surged outward across the inner solar system. Traveling at over 1,000,000 miles per hour, it was predicted to sweep through the region where 3I Atlas was then passing. Solar physicists immediately took notice. These ejections can strip the outer layers of a comet, trigger fragmentation, or even vaporize smaller bodies entirely. For a fragile interstellar traveler, this was supposed to be the moment of truth, a stress test written by nature itself. And yet, when follow-up imagery came in days later, the object was still there, unaffected, unbroken, unmoved. On September 27th, observations from the Subaru telescope in Hawaii showed a mild brightening in its coma, a sign of ionization, not destruction. 2 days later, the same region was re-imaged by ESA's Mars Express orbiter. The result? No sign of tail disruption, no plume of debris, no change in trajectory. The coma had expanded slightly, perhaps energized by the blast, but the nucleus held firm. In the words of Dr. Paulo de la Cruz of the European Southern Observatory, it's as if the object absorbed the CME instead of resisting it. That comment wasn't metaphorical. Spectral readings hinted at a brief surge in charged particle emissions from the object itself, almost like a mirrored response to the solar event. For several hours, 3I Atlas glowed faintly in ultraviolet wavelengths before settling back to its previous luminosity. What could cause that? Typical comets, made of ice and porous rock, are poor conductors of electricity. But metallic or composite bodies can channel and redistribute solar charge, in essence, acting like a cosmic capacitor. If 3I Atlas possesses a dense metallic core, the CME could have induced temporary surface currents, creating the observed flash. The implication left researchers unsettled. A comet acting like a conductor? That's not supposed to happen. Even the official NASA memo, quietly posted to an archived server a week later, avoided direct interpretation. 3I Atlas demonstrated remarkable stability following solar interaction. Further data are needed to determine the mechanism of energy redistribution. Behind the scenes, other agencies were watching closely. ESA's ExoMars Trace Gas Orbiter had captured partial telemetry during the event. Those frames, still unreleased, reportedly show variations in plasma density around the object that defy conventional comet models. An anonymous engineer from Darmstadt described it bluntly in an internal message later leaked online. We expected chaos. We found coherence. Meanwhile, NASA's Deep Space Network, which relays data from Mars and beyond, logged several unexplained transmission dropouts during the CME's peak, affecting spacecraft positioned to view 3I Atlas directly. The agency blamed solar interference, but to those following the timeline, it looked like another layer of coincidence stacking perfectly atop the others. By early October, the narrative had split into two camps. One saw an ancient, indestructible comet, its mass shielding it from even the fiercest solar storms. The other saw something else entirely, a body built, not born, to endure what nature could throw at it. As the sun's plasma storm faded into the void, 3I Atlas continued its silent journey, glowing faintly behind the solar glare. It had survived what should have shattered it, and in doing so, it deepened the mystery of what it truly is. At this point, the conversation began to drift away from hard data and towards something more elusive, meaning. If 3I Atlas was not behaving like a normal comet, and if it could endure a direct hit from the sun's fury, then what was it really doing here? Among the voices trying to answer that question was astrophysicist Dr. Suzanne Fenner, whose work at the University of Geneva focused on planet formation. Her idea was as audacious as it was poetic. Perhaps 3I Atlas wasn't a relic of destruction, but a seed of creation. According to Fenner, young star systems often lack the time needed to grow planets from dust alone. Disks of gas and rock swirl for only a few million years before stellar winds blow them apart. That window seems too short for massive planets like Jupiter to form naturally. So, what if nature found a shortcut? Fenner's simulations showed that when a large interstellar body enters a newborn system, one already rich in gas and dust, it can act as a ready-made nucleus, a gravitational anchor around which material rapidly accumulates. In other words, a foreign object could jumpstart the birth of a planet. Her voiceover in a European broadcast captured the thought succinctly. Perhaps interstellar visitors are not accidents. Perhaps they are how worlds begin. In this view, 3I Atlas isn't a cosmic drifter or an alien artifact. It's a messenger of creation, a fragment from another star that once kindled planets in its own system, now wandering to pass that gift elsewhere. The idea found surprising support. Data models suggested that massive stars are far more efficient at capturing interstellar objects than smaller ones. And statistically, gas giants like Jupiter are indeed more common around massive stars. Fenner's conclusion was simple yet profound. The correlation might not be coincidence. Interstellar visitors like Oumuamua, Borisov, and now Atlas could be the very mechanism by which the universe sows new worlds. It's an elegant theory, one that replaces fear with awe. Instead of asking whether 3I Atlas is spying on us, it asks whether it once played the same role here, billions of years ago, when Earth was still dust and vapor. For a moment, The tone across scientific circles softened. The discussion turned philosophical. Could our planet owe its existence to something like this? Could life itself be linked to the quiet migration of interstellar seeds? In an online lecture, Dr. Fiener smiled faintly as she ended her talk. Perhaps every star system is part of a cosmic garden, and these travelers are the gardeners. The comment drew quiet applause, and a flood of speculation. Because if she's right, then 3I Atlas is not just a visitor. It's a reminder that in the vast, cold machinery of the cosmos, there might be purpose woven into the randomness. That creation might not be isolated, but shared, carried from one sun to another by these silent, ancient messengers. And while NASA's silence continued, that interpretation, hopeful, almost spiritual, began spreading online. For the first time since the blackout began, the story of 3I Atlas was no longer just about secrecy or fear. It was about possibility. As October draws to a close, the red planet has turned its far side toward the sun, and 3I Atlas has slipped once more into the glare. No new data has been released. The citizen archives have gone quiet, and the servers that once streamed orbital telemetry now show nothing but static updates and maintenance notices. For some, that silence feels anticlimactic, a mystery half told. For others, it's fitting. Because 3I Atlas was never just a question of science. It was a reminder of how fragile our connection to the unknown can be. How, in one moment, the universe reveals itself, and in the next, it hides again. Up there, beyond Mars's faint orange glow, the object drifts onward. It's now accelerating toward perihelion, the point where it will pass closest to the sun before it's flung back into interstellar space, perhaps never to return. If the projections are right, its trajectory will carry it past the orbit of Mercury, through a corridor of intense radiation and magnetic turbulence, before vanishing into the black beyond. Whether it's stone or steel, relic or messenger, no one knows. But every telescope that catches even a fragment of its light is looking not just at an object, but at a story written across billions of years and billions of miles. When future astronomers trace the path of 3I Atlas through the data, when they scroll through the missing frames and wonder why so much was left unseen, they may realize that this was never about evidence alone. It was about timing, the moment when science met silence, the moment when humanity looked away, just as something extraordinary came near. Perhaps one day, another interstellar traveler will pass close enough for us to see clearly. Perhaps next time, the channels will stay open. Or perhaps, as Dr. Fenner suggested, these travelers aren't meant to be captured at all, only glimpsed, fleeting sparks in the dark, reminding us that the universe still has secrets it intends to keep. And so, as the last of 3I Atlas's reflected light fades behind the sun, we're left with a single, unanswerable thought. Maybe what we witnessed wasn't a cover-up or a coincidence. Maybe it was something simpler, a quiet handshake between two worlds, one human, one cosmic, each acknowledging the other, then drifting apart once more. No announcement, no fanfare, just the soft hum of solar wind carrying it away.